In 1938, at Columbia University, a physicist named Isidor Rabi aimed a narrow beam of molecules through a magnetic field and watched the quantum world respond. Rabi wasn't searching for a cure or building a machine. He was chasing a question. What happens to atoms when you magnetize their universe? Rabi discovered that some atomic nuclei behave like tiny magnets. When placed in a magnetic field, they don't just point and stay, they wobble, tracing a path called a precession. If you hit these spinning nuclei with just the right radio frequency, they absorb the energy and then echo it back. This was the birth of nuclear magnetic resonance, or NMR. It was invisible, delicate, almost ghost-like. But it told physicists something profound. Atoms speak if you know how to listen. In 1944, the Nobel Committee awarded Rabi the prize in physics, not for curing disease, but for revealing a fundamental truth of nature. Funny thing is, Rabi had no idea his experiment would one day help diagnose cancer, monitor brain activity, or image the heart. For him, it was just quantum curiosity. After World War II, two physicists, Felix Bloch and Edward Purcell, picked up where Rabi left off. But they had something Rabi didn't: better electronics and a war-tested hunger for precision. Rabi's breakthrough involved atomic beams in a vacuum, an elegant but delicate technique. It worked, but only for isolated atoms, under perfect conditions. Bloch and Purcell asked, what if you could do this in bulk? Not beams of gas, but real substances, water, oil, solids, things you could hold. They placed a sample, like water or alcohol, inside a strong magnetic field. The protons inside began to align, their tiny nuclear spins behaving like spinning tops. Then they zapped the sample with a carefully tuned burst of radio waves. This knocked the nuclei off balance. As they relaxed, they gave off a faint magnetic whisper. But here's the magic, they whispered back differently. The shape of the signal depended on its atomic environment. Different atoms, different arrangements, different signals. You could identify a molecule's structure without breaking a single bond. It was a chemist's dream, a molecular fingerprint. Suddenly, the invisible became legible. In 1952, Bloch and Purcell shared the Nobel Prize in Physics. This wasn't funded by IBM, or NASA, or a hospital. It was a few young researchers working under Raymond Damadian, building something no one had ever seen before, by hand. They were picking up where Rabi, Bloch, and Purcell had left off. The physics of magnetic resonance was already there, but no one had ever used it to see inside a human body. Until now, NMR had been confined to chemistry labs, analyzing tiny vials of liquid. The idea that you could scale that up, surround a person with a giant magnet, and extract an image from their tissues, that bordered on science fiction. But Damadian believed it could work. He had already shown that cancerous tissue gave off a different magnetic signal. Its protons relaxed at a different rate. The key was to build a machine that could detect that difference across the whole body. They weren't just scanning bodies, they were inventing a way to measure time inside tissue. Not clock time, proton time. The subtle, ghost-like echo as each nucleus returned to rest. They called the machine Indomitable because it had to be. It was noisy, immense, barely controllable. And it took 4 hours to scan just one person. In 1977, after years of trial and error, they activated the full-body scanner. Adjusted, calibrated, waited. And then, on a screen filled with static, something appeared. A human being, seen from the inside. No scalpel, no radiation, just magnetism. For the first time in history, we could look inside a living body, non-invasive. But while the breakthrough was real, the recognition would be far messier. Because while Damadian's scanner was first, it wasn't fast. And another scientist, working quietly elsewhere, had a different idea, one that would make images sharp, elegant, and, some argued, more worthy of history. Nearly 3 decades after the first human MRI scan, the Nobel Prize was finally awarded for magnetic resonance imaging, but not to Raymond Damadian. Poor Lauterbur had an insight that changed everything. He realized that by adding magnetic field gradients, tiny spatial variations. You could encode where a signal came from, not just what it was. Before this, NMR gave you data, but Lauterbur made that data imageable. A signal wasn't just a spike, it became a place, a picture. Peter Mansfield took Lauterbur's concept and made it practical. He used rapid switching gradients and clever math to turn scans that took hours into minutes. It was faster, sharper, more usable, and with it, MRI left the realm of experimental physics and entered the hospital. Damadian didn't take it quietly. He protested, he published, he took out full-page ads in the New York Times. He felt robbed. Mansfield and Lauterbur received the Nobel Prize. For Damadian, it wasn't about technique, it was about vision. He believed he lit the fuse. Without his idea, without Indomitable, there might have been nothing to refine. And maybe he was right. Maybe they all were. Damadian had the idea, Lauterbur gave it structure, Mansfield made it work. To this day, scientists still debate who truly invented MRI: the visionary, the refiners, the builders?